Okay, so we're going to talk about this a little bit today, but first, I want to go in here and on Canvas, let's look at our schedule. So today is the 27th. So this is not, what we're going to talk about today is not really today's assignment. Okay, so if you have questions on what you need to do today, we can kind of play with that. But what you're going to do today is actually in your book. Can you guys all see my screen? You see these papers? Okay, so you should have your book with you. So if you open up to page 228 of your book, it's in there. Okay, and you just need these 2 pages. I know this document has more pages in it, but you just need 228, 229. You're just going to fill out these questions, okay, as you do this activity. See on here at the top where it says use dynamic geometry software? Well, there's actually a link for that software in Canvas, and it brings you here. Okay, nod again if you can see my screen with the geometry tool on it. Okay, so just to give you a quick preview, if you were to just push the segment tool, you could just draw a line segment. Okay, and then it specifically asks you to build a parallelogram. So you're not just gonna willy-nilly go and put another segment in there. You're gonna go like this. You see this more tools thing over here? We can force the next line that we draw to be parallel. So it says choose a line to set the slope. Click on it. Now, whatever I do, that line is going to be parallel to the one I already drew. Okay, so that's going to be a good start for getting a parallelogram drawn. Then if I connect these two, I'm dang close to having my parallelogram. So I go to more tools and create parallel again, because this time I want it to be parallel to that one. And I've created a parallelogram. Okay, so it kind of talks you through that. There is a page of hints and tips and whatever for that in Canvas. But there, if you need more help with it or whatever, I'm happy to help you. You can just hop in this Zoom room, and anytime I'm on the computer, it will alert me that you're in here. Or you can send me a quick email and just say, hey, can we chat on Zoom so you can show me what to do on the computer? And I would love to, because otherwise I'm just sitting here grading Canvas assignments, and it is the most boring thing of my life. Okay, all right, so back to Canvas. So the 27th, so today and Monday, depending on which day you do your homework, if you try to stay A-B schedule, or if you try to go Monday, Wednesday, Friday, hopefully it works either way. You're gonna do the assignment in the actual assignment. So actually in the Canvas assignment, it gives you all of the very detailed instructions. A lot of instructions for this particular little friend, okay? And then it'll tell you exactly what you need to upload to get that assignment done. It's a lot of instructions, but it hopefully won't really actually take you that much time to do it. If it's taking you forever, just stop. And like if you spend more than, let's say, 40 minutes on it, don't. Just stop. Okay? And just email me and say, I did my best for 40 minutes. I'll send you what I got. How's that? I don't really know how long these things take. So if they're taking you way too long, please tell me, because I don't want you doing things that are taking hours and hours. Okay, so that is what you're going to do today and Monday. And then the thing that I wanted to go over with you is these notes right here. Okay, so if you haven't seen this yet, and you're seeing it for the first time, just take a minute and let that sink in. Actually, I'm going to open it up on here. Okay. All right, so on this page, what is a quadrilateral? Somebody unmute yourself and tell me what a quadrilateral is.
Four-sided shape.
Good. It's just a polygon, or the friendly, easy word for that is a shape that has 4 sides. So that's where this quad comes from, quadrilateral, okay? And then there are all kinds of quadrilaterals. The ones we're gonna focus on in this class show up on this paper. So there are parallelograms. That's probably the biggest distinction that we are going to use. And then rectangle, rhombus, down here at the bottom, you get square. Over here, these ones are a little bit different and we don't use them a lot. So we have kites, we have trapezoids, and then there's a super specific classification, which is called an isosceles trapezoid. And like I said, we rarely use any of these. In fact, on your assignment that you're going to use these notes for, you're never going to come over here. We'll call this the dark side. We're going to avoid the dark side, okay? We're going to stay over here with things that start out as parallelograms. So a parallelogram is just kind of like I just drew in the geometry tool over here. You've got a set of parallel lines and another set of parallel lines, then you get a parallelogram. And you can do all kinds of things with it and keep it parallel. It doesn't have to be big. It can look kind of like a square. It can look like a rectangle. Yeah, look, kind of looks like a diamond. Yeah, all kinds of parallelograms. But when we talk about these properties, different properties will tell you if it's just a parallelogram or if you can get more specific and call it a rectangle, a rhombus, or even a square. So this is, quadrilateral is super broad. That encompasses a lot. Parallelogram is a little bit more specific. It's actually pretty specific. I mean, a quadrilateral is anything with 4 sides. So parallelogram is pretty specific. But then rectangle and rhombus are even more specific. That just means they have more properties than parallelograms do. And then a square, did you guys know that a rectangle and a rhombus combined makes a square? Like if you have all the attributes of a rectangle and all the attributes of a rhombus, then you're a square. Like they made a baby and the baby got all of the genetic traits from mommy and daddy. Neat. Don't smile. Don't. Junior, don't smile. Wow, you guys are terrible at listening to directions. Terrible. Okay. All right. Just wanted to see if you're still listening. Okay. All right. So when you go to do your assignment, your assumption is that everything is already a parallelogram. You're going to be looking at the shapes on your assignment to see if they have any special markings that make them more than just a parallelogram. Okay. So I'm going to show you. Maybe I have too many things open on my computer. There it is. Okay, so this page, this is your assignment that goes along with that notes page that I just barely had open. Okay, raise your hand if you think that all of those shapes look exactly the same. They do. They are actually the same. They were all drawn the same. But what happens in math and in geometry is that you're only allowed to assume they're the same if the markings tell you they're the same. Kind of like you're only allowed to assume that something is a right triangle if they actually put the little square in the corner. Okay, you don't know it's a 90-degree angle until they tell you it's a 90-degree angle. So for instance, on this one, on these pictures, it looks like all 4 sides. They all kind of look like a rhombus. If you guys are familiar and you remember what a rhombus is, they all look like a rhombus. They look like they have 4 congruent sides. Do any of them look like squares? Just shake your head, yes or no. Do any of these shapes look like a square? Oh, you all froze. Did I freeze? Hello? Hi. Did I kick you all out for a second? Oops. Sorry. Okay. So I had a question for you. Did we get to the point where I asked you if it was a square or not? Did you hear that? No? Okay. Do all of these shapes, let me go back to sharing my screen. Maybe. Okay. What shape do these all look like? I think they all look like a rhombus. Yes? Does everybody agree? Okay. So the question is, do any of these look like squares? What do you guys think? Do any of these look like squares on this page? Yes, no? If I asked you to draw a square and you drew it like that, I would be a little bit disappointed. Okay, squares are supposed to have right angles. True? True? Yes. Okay, so these actually all are, if you technically just broke down what this actual shape is, every single one of them is a rhombus. They have 4 congruent sides, but they do not have 4 right angles. However, you're not looking at that. You're not judging the shape based by its overall look. You're going to judge by its markings. So let's really quick talk about markings. What do these, you can unmute yourselves. What do these little dashes on the sides of the shape tell me?
That they're congruent.
That they're congruent. So on shape A, a single dash right here and a single dash right here tells me that those two sides are congruent to each other. And then the double dash, stop barking, you're so annoying. Sorry. They were so quiet for all of my other meetings. I don't understand. And then double marks tell us that those are congruent, but the reason there's single marks and double marks is because these ones are congruent to each other, but not to the other two. Okay. All right. What do these little like arrow chevron things, what do those tell us? Whitney, you're still unmuted. You go. I don't know why this keeps happening. I'm so sorry. Okay, I'm just gonna be quick because I don't know. Yeah, I don't know what's happening. Okay. All right, so really quick, back to that document that I now can't find because my computer is being dumb. Okay. All right, so really quick, the little angled ones, the little chevron marks, yes? Those are just telling us that the lines are parallel. Okay, so this one on shape A, we know that these opposite sides are both parallel and congruent. They're the same length. And then this pair of opposite sides are parallel and congruent. Okay, let's look at shape B really quick. These are called diagonals. Okay, and in this case, the diagonal has been cut into 2 equal pieces. So that means that this diagonal has been, I'm going to throw out some vocabulary here. This diagonal has been bisected by this diagonal. They just cut each other into 2 equal parts. Good. And then angles, if you get a single, see these little arcs in these angles, those arcs are telling you that those angles are congruent. The double arcs over in E in the corner are telling you that those angles are congruent. Yeah? Just a nod, an affirmative. Yes, you know what all those things are. Okay, are there any things that you see in that picture that you don't understand? Any markings? Good. Okay. All right. So when we're looking at the notes page, let me explain this really quick. So in the blue-ish colored boxes, you get just in general properties of a parallelogram or properties of a rectangle, properties of a rhombus, whatever. Okay. So when you look at this box, at the box that says parallelograms, these are all the things that are true about parallelograms. Their opposite sides are always going to be congruent. Their opposite angles are always going to be congruent. Their consecutive angles are always going to be supplementary, and the diagonals are going to bisect each other. But do you guys remember on your, just recently on your geometry stuff, you were using like angle, angle, side, and side, angle, side, and all of that stuff? Does that ring a bell? Like side, 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 yes? Those are just shortcuts. So triangles aren't congruent unless all of the sides are congruent and all of the angles are congruent. But that's really irritating to have to find all 6 things every time. So there are shortcuts. Well, these are the things that are always going to be true, but you don't have to know all of the things in the blue square or the blue rectangle in order to determine that something is a parallelogram. You can use just something in this pink box right here. Okay, so if you had a shape and both pairs of the opposite sides were congruent, then you could say that's definitely a parallelogram. Okay, if you, hold on. If you knew that both diagonals bisected each other, if that's all you knew about the shape is that it had 4 sides and that both diagonals bisected each other, then you could say it's a parallelogram. Okay, and same with all of these bullets, they're just shortcuts that you can use to for sure determine that something is a parallelogram. On your assignment, you don't really need all of those shortcuts, I guess. More than anything, you're going to be using these ones down here. Oops, I don't know why I just did that. Okay, so down here, I want you to pay close attention to what it takes to move from parallelogram into rectangle or rhombus. So if you know that something is a parallelogram, but then I tell you that the diagonals are congruent. So if I tell you that the diagonals are the same length, then you know that it has to be a rectangle. Or if you know that it's a parallelogram, and then I tell you that one angle is 90 degrees, all 4 angles could need to be 90 degrees. But if you even know that just one angle is 90 degrees, you're automatically a rectangle. Does that make sense? Yeah? Okay, and then over here, if I want something to be a rhombus, it has to have one of these 3 things. A pair of congruent consecutive sides. That just means that, I'll show you a picture. Nope. That just means that instead of opposite sides being congruent, like here and here, instead of opposite sides being congruent, if consecutive sides are congruent, then we are guaranteed that all 4 sides will be congruent. Therefore, it's a rhombus. Okay? Diagonals are perpendicular. What does it mean for diagonals to be perpendicular? Somebody unmute yourself. What does it mean to be perpendicular?
Makes a T.
Yeah, it makes a T, and it makes a right angle. So if I have a shape and the diagonals, oh gosh, the diagonals make a 90-degree, oh, please be nice. Oh, that is not a 90. Close enough. So if the 2 diagonals make a 90-degree angle right here, then you know for sure that that's a rhombus. Okay? And then in order to be a square, you would have to have met one condition from the rectangles box and at least one condition from the rhombus box. If you meet one of each of those, then it's a square. Okay? Does that help you guys a little bit? All right, so really quick, back to this thing. This is going to be your first assignment. Okay, so creating parallelograms in here. You'll need this more tools thing, remember, to get your parallel lines. It gives you a hint, but I'll just show you guys since you're already on the screen with me. When you have to measure angles, if you click on angle, it says choose a point, and then choose a point, and then choose a point. Really, like if I wanted to measure this angle right here, I just need to trace it. So go from here to here to here, and that's going to tell me that that angle is 110 degrees. Okay, but then if I want to, I can just start moving things. It's not going to stay 110 degrees because I changed it. Yeah, but if I now measure this angle, I don't think I have a dot there. Oh, I can. Dot, dot, dot. Okay, even if I change this shape, those two numbers are always going to add up to 180 degrees because it's a parallelogram. Okay, they're called consecutive angles. They'll always add up to 180 degrees. Yeah? Good? Okay. It will also ask you to measure side lengths. Let me just show you really quick how to do that. So if you click on the segment tool and highlight a side, nope, just kidding. I did that wrong. You just select, sorry. You just select a side, then down here, oh my goodness. Then down here, after you've selected it, see where it says measurements, length, add label. It'll tell you how long that side is. Okay, so then I'm gonna do it to this one. Measurement, oh, I can't. How come I can't? Anybody know? Anybody know why I can't measure that? You have to unmute yourselves and tell me. Why when I click on this, can I not measure it?
Because
it's infinitely long. Look, it goes on forever and ever and ever. Okay, so we need this to be just a segment. I'm gonna make a segment just from here to here so that I can select just the segment. Now I can measure the length. And if you are shocked and shaken, shocked and shooken, I don't know, you choose. If you are shocked that these two things are the same length, then we maybe have a problem, maybe, in your understanding of parallelograms, but it's okay. I still love you. I'll help you. Good? Okay. All right, let me go back to here to see all of your beautiful faces. Dang, she's good at check marks. Thanks, Whitney. I couldn't see any of your comments while I was sharing my screen. How sad. Yeah,